Okay, so we are going to look at linear models, and then we're going to see how can we figure out that it's a linear model, and how can we find that from tables, graphs, and equations. So tables, graphs, and equations are all examples of mathematical models, right? So a mathematical model can be given as a table, as an equation, or as a graph. Okay? Now, linear models represents quantities that increase or decrease by a. You remember from grade 11 when we did linear functions and we did tables? What was constant? Do you remember when we did the first difference, second difference, the ratio? Do you remember that? Do you remember which one was constant for linear? Degree 1. It's the first difference. The first difference was constant,
yes,
right?
Yes.
So linear models represents quantities that increase or decrease by a constant amount. Okay? So let's say if I want to say that, let's say I'm gonna pay you $10 per hour, right? If you work 1 hour, you get $10. If you work 2 hours, you get $20. If you work 3 hours, you get $30. So that's a constant amount that I'm adding for every single time I increase by 1. Right? So it represents quantities that increase or decrease by a constant amount over a constant interval. Or over an equal. Now, if we're talking about linear model, the graph is what kind of graph do we have for linear? Linear would have what kind of graph? Would it be parabola? Would it be a straight line? Would it be flat on one side? For linear. Linear. The word linear comes from what? Straight line.
Okay.
Right? They should be related. So the graph is a straight line. So if I'm looking at a graph for a linear function, it's going to be straight line. The equation of a line can be written in the form of, what's the degree for a straight line for linear? Degree 1, right? So the equation will be written as y equal mx plus b, where m is the slope and b is the vertical intercept. Do you remember this?
Yes,
It's coming back to you?
It is.
Yes. So you look at this, the degree on the x is 1, right? So it's a degree 1. And the rate of change is constant. Because the rate of change is going to be related to your slope. Okay? So, which model represents a linear relation? Because it's given to you in a table format, what do you have to know? What do you have to do to figure out if it's linear or not? If it's a table, you have to do the first difference. If the first difference is constant, that means it's linear. If the first difference is not constant, that means it's not linear. Okay? So the first difference, if you guys remember, it's y2 minus y1. You remember that? Mm-hmm. So if I do y2 minus y1, so I'm doing 55 minus 60. I'm going to get negative 5. If I do 40 minus 55, I get negative 15. 15, take away 40, I get negative 25. Is your first difference constant? No. So is it linear? No. So this is not linear because the first difference is not constant. Does that make sense? Let's look at the second table. Okay? So again, in order for me to figure out if it's constant, I'm going to have to look at the first difference, if it's linear, sorry. And then I have to do y2 minus y1. Okay? So what's y2 minus y1?
40 minus 0.
40 minus 0, which gives me
40.
40. Then,
80 minus 40.
which is 40. Then, 120 minus 80, which is 40. What do you notice here?
That's constant.
It's constant. So the first difference is constant, therefore,
It's linear.
it's linear. This is what we did last year in our first lesson. Okay? So whenever you're given a table of value, you want to do the first difference to figure out if it's linear or not. Let's look at the C and D. Can you look at both graphs and tell me if any of them is linear, and if any is linear, which one? C is linear because it shows a straight line, right? Does the second one shows a straight line? No. Okay. So straight line, so therefore it's linear. And the second one, not a straight line, so it's not linear. Out of the two equations that you see in E and F, can you tell me which one might be linear? Or which one is linear, which one's not? Is the first one, what's the degree on the first one? What's the degree in here? Y equals 2x plus 5. What's the degree on x? What's the degree? What's the exponent on the x? What's the exponent? What's the exponent on the x in the second one?
Oh, it's not 1.
That one's 1, right? So this is an exponent 1 here, right? Degree 1. This is degree 2. Which one's linear? So the first one, because it has a degree 1. Remember, guys, it should look like y equals mx plus b, right? So it should look like y equals something x plus something, right? So if you look at this, it's 2x plus 5. 2 is replacing the m, 5 is replacing the b, right? And then x.
Yeah.
X has a degree 1, okay? So if it has a degree 1, that means it's linear.
Okay.
If it has a degree other than 1, it's not linear. What do we call this? Starts with a Q. Quadratic.
Oh, okay.
Right? So anything that's not degree 1, like degree 2, is called quadratic.
Okay.
Right? So this is linear. So it looks like y equal mx plus b with a degree 1. Right? It's degree 1 on the x. So that means it's linear. This one, it's degree 2, so it's not linear. We'll discuss quadratic in the next lesson. Okay? Are we okay with this? So in real-world graphs of linear relations, the vertical intercepts represents the initial value of the dependent variable. So when I say the vertical intercept, so which one is vertical? X or y? Which one is vertical? Y is vertical, right? So if I'm graphing a line, look here for a second. The vertical intercept is, what else do we call it usually? Instead of calling it the vertical intercept, what do we call it? What do we call this usually? We've called it the y-intercept, right? We call it the y-intercept. Okay? The only reason why they call it vertical intercept is that it's not always called y. It could be called p, it could be called f, it could be called whatever, right? So they can change the letter for the y. Okay? But vertical intercept is the same thing as a y-intercept. So it represents the initial value of the dependent variable. Okay? That means this is my starting, this is when x equals 0. Right? The y-intercept is when x is equal to 0. That's why it's called the initial, at time 0. Okay? The slope represents the steepness of the line. Remember that from before? And it also represents the rate of change. Okay? So I'm not sure if you remember, if you recall, when we did the review long time ago, when we were drawing a linear function, so let's say if I have y equals 2x plus 3. Okay? That means, where's my y-intercept? So this is the same thing as mx plus b. Yes? Now, if you go back to the previous page, and it says in the previous page, m is the slope. So what's my slope here? What number represents my slope? 2. So 2 is my slope. And then b represents what?
The vertical intercept.
The vertical intercept or the y-intercept, right? Good. So now, if I'm looking at graphing this, I'm going to start from the y-intercept. Okay? So my y-intercept is at 3. So I'm going to go 1, 2, 3. And this is where my y-intercept is. Okay? The slope says it's 2. So that means I'm going to have to go up 2 because slope is rise over run. And I'm sure when I say these things, it rings a bell for you, right? Slope is rise over run. That means I have to go up and over, right? If it's 2, that means I'm going to have to go up 2. So I have to go up 1, 2, and I have to go over 1. And that would give me my next point. Okay? So if it's 2 over 1, that's what 2 means. So that means I'm going to go up 2, right to the right 1, over 1. Okay? So again, from this point, I'm going to go up 1, 2, and I'm going to go over 1, and I'm going to get to my next point. So you see that my line is like this. Does that make sense? How am I graphing linear functions? Okay? You always start with the y-intercept, and then you use your slope to find your next point. Are we okay with that? Okay. Let's look at a word problem. A cup of coffee is reheated in a microwave. The temperature, C degrees Celsius, of the coffee after T seconds can be modeled by the following linear equations. Explain what the numbers in the equation represent. How do the two equations compare to each other? Okay, so I have two different microwaves, 500-watt microwave and a 1,000-watt microwave. Okay, and then the equation for the 500 is C. C represents what? C represents what? The degrees. So C represents the temperature, right? So C is equal to 0.5 T. What is T? Seconds. Okay. So if you put the coffee in the microwave for 1 second, right? What's going to happen to your temperature? It's going to increase by how much? By 0.5. Right? Because it's 0.5 times how many seconds you put it in.
Oh, okay.
Right? And then plus 20. What does that 20 represent?
How many seconds?
Seconds is just T. Plus 20. 20 represents what? So if you're looking at your equation, that's the same as writing y equal mx plus b. What does 20 represent? The y-intercept. Okay, eyes on me for a second. C is replacing y, so that's the temperature. Okay? And T, which is time, is representing the x. Okay? Look at me for a second. My y-intercept is 20. So that's where my y-intercept is. That 20 represents what? The y-intercept, which is what? 21. That's the temperature, right? That's the starting temperature. So right now, my coffee is at 20 degrees, right? Before I put it in the microwave. That's my initial temperature of the coffee before I put it in the microwave. Right? Now, when I put it in the microwave, what's going to happen for every second I put it in the microwave for the first equation? By 0.5. For every second, okay, the temperature is going to go up by 0.5. Okay? Good. Now, if I look at the second equation, what's the slope here? What do I put here if there's no number in front of the T? 1. Now, what's the initial temperature for the second equation? What's the initial temperature here?
20.
20. So it did not change, right? Good. Now, what's going to happen to the temperature of the coffee for every second I put it in the microwave?
Go up by 1.
It's going to go up by 1 degree. So if you put it in a 1,000-watt microwave and you put it for 10 seconds, your temperature is going to go up by 10 degrees. Okay? Eyes on me. We'll write it together. Okay? If I put it in a 1,000-watt microwave for 10 seconds, my temperature is going to go up by 10 degrees. Correct? If I put it in a 500-watt microwave for 10 seconds, how much my temperature is going to go up by? 5 degrees. Right? Because it's only going to increase by half a degree for every second I put it in. Right? So if you want the temperature to be, whatever, a certain degree, you have to figure out how much you need to put it in each microwave. So some microwave you need to put it in for 30 seconds, but another microwave you need to put it in only for 15 seconds, right? Because they're going to give you the same result. Okay? So, the question is asking us, explain what the numbers in the equations represent, and how do the two equations compare to each other. So let's write that. So the coefficient of t, so 0.5 and 1, are the rates of change. So they're the slope, right? Are the rates of change. You guys have to understand that rate of change and slope, they mean the same thing. Of both temperatures with respect to time. So it's going to go up, so 0.5 degrees Celsius in 1 second for the 500-watt microwave, right? And it's going to go up by 1 degree Celsius in 1 second for the 1,000-watt microwave. And the constant 20 in both equations is the initial temperature of the coffee. So that's at time 0. So before I put it in the microwave. Are we okay with this? Now, so in real life, we're not going to be given an equation right away. We're going to have to figure out an equation. So when we're collecting data, or when we have some data collected previously, they're going to be given to us as points, right? As x and y values, and then we have to graph them, okay? And this is what we usually get. Eyes on me. So we usually get something that looks like this. Right? Some points, some random points, right? We're going to have to figure out what is the equation. Okay? We can do this by hand and spend time and whatever, but then we have now these days all these technologies that we have that we can use to figure out the equation by just plotting the points. Okay? So we call that, if we're using the technology, we do a regression line. Okay? So we can use linear regression to model data that appear to be linear, iterated. The regression line equation can then be used to analyze the data and make predictions. The closer the regression line is to the data, the more reliable the predictions are likely to be. So if I get points like this, I can use the Excel. We're going to try to use Excel. And then I can ask Excel to create a line of best fit. That's what LOBF means, right? It's a line of best fit. So the Excel sheet will create for me a line of best fit and will give me an equation of that line of best fit. It will give me an equation, okay? Will tell me that y equals this, 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 okay? So let's see how can we do this. So let's look at actually what I want you to do right now is I want you to log into the computer and find Excel. That's what I want you to do, and then we'll start that question.